Get some function using first principle. The first principle is given like this. Okay, so if we have this is the formula of the first principle. So let's apply that. Differentiate f of x is equals to the square root of x. We're going to use that as an example, all right, to show you how you use this formula. So we're going to plug this into that formula right away. We have this limit square root of x plus h. Now instead of writing f of x plus h, you write your f of x is this function, so this is how you write it, then minus f of x, which is the function given to you, all over h. This is how it will look like. Now the next thing you're going to do is, since this is in a sort form, you're going to get the conjugate of this as sort, and you multiply the numerator and denominator by the conjugate. We're actually like rationalizing the sort. Okay, so we have limit as h approaches 0, x plus h minus root x all over h. You're multiplying by the conjugate, x plus h. Now the conjugate now become positive. The original sort negative, the conjugate positive. Okay, and you are multiplying both the numerator and the denominator by the conjugate. So this is what you have. All right, we can still group them in brackets, you know. So grouping them in bracket, we're going to have this square root of x plus h root x. Okay, square root of x plus h plus root x all over, you can bring a bracket here, x plus h plus root x. Now that's you grouping them in bracket. The next thing you're going to do is you're going to expand the bracket, especially in the numerator. That's the one up. So you have the first square root here, root x plus h multiplying root x plus h in the second bracket. They have the same base. Okay, according to indices, square root is something like power of 1 all over 2. So you're going to add 1 all over 2 plus 1 all over 2. You pick one of the bases, all right? So that gives you x plus h, all right? Then you do the same multiplication. You expand the bracket. The next term would be root x plus h, all right? You do the same thing here, minus root x multiplied by the square root of x plus h. You have minus root x, then you have this here plus h, then you have minus root x plus root x. That's going to be minus x, all right? So you have all over, you bring down your denominator. This is what you have in the denominator. Now if you look at this closely, these guys can cancel each other because this one is positive, this one is negative, all right? So that's gone. So that reduces your numerator down to x plus h minus x. Okay, you bring down your denominator, x plus h in square root plus root x, close the bracket. All right, just to look at that closely, you discover that there are cancellation that can still be done in the numerator. This guy and this guy can go, all right? So you're left with limit as h tends to 0, you have h, then you have h under root x plus h plus root x. This h can go, alright. You have limit as h tends to 0, you're left with 1 in the numerator. You have x plus h plus root x, but they said your h tends to 0, okay? So you're going to implement that now by putting h as 0, alright? If you do that, you have root x plus 0 instead of h because h tends to 0, okay? Root x. This is going to be what? Strictly, let's say 1 over root x plus root x. One over 2 root x. This is the final answer, okay? Because you have 1 over root x, 1 over root x. You're adding them, so it's 2 root x, which is the